Welcome back to the final installment on the topic of system of equations. The first two problems that you see on the screen are rather simple. They're just merely there for practice. So let's go ahead and solve them. So the first problem is actually particularly very simple. So 2x plus 3y equals 10, negative x plus 5y equals 8. If you multiply the top expression by 1 and bottom by 2, this way we can get rid of the x term. So 2x plus 3y equals 10, negative 2x plus 10y equals 16. So this will be 13y equals 26, y equals 2. Therefore, 4y equals 4 times 2 equals 8. Okay. Let's do the bottom one. 4x plus 3y equals 6. 2x plus 2y equals 4. So it really is up to you whether you want to get rid of x or y and whether you want to use method 1 or 2. I chose method 1. So if I multiply the top equation by 1 and bottom by 2, then it leads me to 4x plus 3y equals 6, 4x plus 4y equals 8. If I call this 1 and 2, I subtract 1 from 2. That means it's y equals 2. We don't know, we're asked to solve for x. So that means if you put it into this expression, then we get 2x plus 4 equals 4, 2x equals 0, x equals 0. Okay, an aquarium has 15 fish tanks that holds a total of 70 fish. If all of the fish tanks hold either 4 or 6 fish, how many tanks hold 6 fish each? Okay. So in other words, let's say X is for 4 fish tanks, okay, and Y corresponds to 6 fish, okay. That means the physical quantity of the total fish tanks in stock is X plus Y equals 15, and the 4 fish tanks would be 4X, and the 6 fish tanks would be 6Y, because that's the way we equate it. That's equal to 70. Again, you can multiply the top by 4, bottom by 1, which gives us 4x plus 4y equals 60, 4x plus 6y equals 70, right? Sorry, 15 times 4, yeah, 15 times 4 is, that's correct. Okay, if you call this expression 1 and 2, then 2 minus 1 would be 2y equals 10, y equals 5. Okay, we are equating y to our 6 fish tanks, so y is fish, and that's the answer. I like this problem because if you actually visualize the problem, there's going to be less mistakes. So you have Fred's home to church is 3 miles less than twice the distance from his church to his mosque. If the entire drive is 54 miles, how many miles is his church from his home? So assuming, let's draw the picture. Home to church. Let's call this part 1 of the distance. Okay, you'll see why. And church to mosque, you don't have to draw it vertically. I just drew it that way because I think the figure looks compact. This is second part of his trip. Okay, part 1 of the trip plus part 2 of the trip is total to 54 miles. Okay, let's call the distance from church to mosque as D, because we don't know that. So is the home to church. But what is critical about home to church is if you assign the correct variable to church to mosque. Okay, we keep this univariate so that distance from Fred's home to his church is 3 miles less than twice the distance from his church to mosque. In other words, it's 2D minus 3, right? Twice the distance from church to mosque minus 3 miles less, right? If you add these two, part 1 plus part 2 is 54 miles. So it's 2D minus 3 plus D is equal to 54 miles. So 3D equals 51. D equals, I believe, is, sorry, 57, is it? Yeah, 57. So D is, it's 19. that, 19 miles, right? You'll be tempted to circle this in the answer choices because that's human nature. But we're not just solving for D. That is the distance from church to mosque. The question is asking the distance between home and church, which is 2D minus 3. So 2 times 19 minus 3, that's 38 minus 3 is 35. You always want to double check your work. Make sure you get 54. 35 miles for part 1 of the trip plus 19 miles for part 2 of the trip. That's 54 miles. I got it. If you didn't get it, you have to redo it. But again, I keep repeating, after you read the problem once, maybe twice, you need to visualize how you're going to do it, which means the first time you read the problem carefully, the second time you read it in parts, and if it doesn't make still sense, skip the problem and come back to it at a later point of time. Okay. Julie has 35 coins, all dimes and quarters. The total value of all her coin is 725. How many dimes and quarters does Julie have, right? So if you assume dime to be X, okay, and Y to be quarters, okay, okay, she has X plus Y is 35 because that's just a physical of however many quarters and dimes she has, okay, and we know a quarter is $0.25 and a dime is $0.10. That important because the total value of our coins is 725. That's expressed in dollars, not just cents. Okay, so that will be 0.25 is our X is dime, so 0.10 X plus 0.25 Y because that's quarter. That's equal to 725. Again, I'm eliminating the sign of dollar for convenience. So we can substitute either Y for X or X for Y. If you call this expression 1 and 2, you have to substitute 1 somehow in 2. So let's do Y equals 35 minus X. That means 0.10X plus 0.25 times 35 minus X equals 7.25, right? So 0.10X plus 0.25 minus 35. That's 8.750 minus 0.25X equals 7.25, right? 0.25 minus 0.10 is negative 0.150X equals 7.25 minus 8.750. That would be negative as well. So 7.25 minus 8.75, that's negative 1.5. Negative 0.150 equals negative 1.5. So X equals 1.5 divided by 0.15. That's 10. So X is 10 coins. What is X associated to? X is associated to dimes, right? So how many, what is the question is asking? How many dimes in quarters? So it doesn't distinguish. You want answer for both. So we know 10 dimes. So X plus Y equals 35. So X is 10. So what is Y? That's Y equals 35 minus 10 equals 25. So she needs 25 quarters and 10 dimes. All right, we're coming to the end of this sequence or series of videos on system of equations. I want you to take the time to go through these problems, pause if needed, and relearn. Sometimes you may not understand the concept in the first go. Give it a shot, you will get it, I promise. Okay. A store sells 17 coffee mugs for $169. Some of these mugs are $12 each and some are $7 each. How many $7 coffee mugs were sold? Okay. So let's say the $12 coffee mugs are X, and then the $7 coffee mugs are Y. We physically know the total head count of X plus Y is 17 coffee mugs, and then the $12 is the X, and the $7 is Y, so 7Y equals 169, right? We're again getting rid of the dollar sign. So again, just like you did in the previous case, if you take y equals 17 minus x, if this is expression 1, this is 2, and this is 3, substitute 3 in 2, which means 12x plus 7 times 17 minus x equals 169. 12x plus is 17 times 7. I can't do it on top of my head. That's 119 minus 7x equals 169. 12 minus 7 is, what is it? 5x equals 169 minus 119. That's 50. So x equals 10. What is the question asking? How many $7 coffee mugs, right? We equated the 7 is y. So x plus y equals 17. So what we found is the $12 coffee mug. So 10 plus y equals 17. So y equals 7. So we have $7 coffee mugs. I'm glad I finished with a coffee problem, because that's precisely what I'm going to do after completing this video, because after this 6-part series on system of equation, the thing I need is a coffee, a giant, big coffee, not $12 coffee mug, not a $7 coffee mug. I probably need a $169 coffee mug, because that's how much caffeine I need. So if you learned something, thank you for watching. Consider subscribing to my channel. Please share the video with your friends who are also learning SAT or ACT math, and stay tuned to my channel. I'll see you soon.